Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video, we're going to talk about variable record length files. So we just wrote a collection that's based upon fixed record length files, where every record in the file has the same length. Now we want to talk about the possibility where the records each have different lengths. And to start off with, we should go ahead and create a type that might need this type of variable length. So if we come in here and we create a new Scala class under our extras package, I'm going to go with a student. And the reason why a student makes a good variable length record is because right up front they have a name. Okay? And a name being a string is going to have a variable length to it. Now you can store things that have strings in them inside of a fixed record length storage system, but in doing so you have to specify like a maximum length for your string. If you don't want to impose that limitation on there, you need this to be variable length. Let's see, an ID, and then I don't know what else I want to, I'm actually just fine stopping right there. This will be sufficient for our purposes. I could come up with things like lists of courses and whatnot, and those would be even better in that different students would have taken different numbers of courses, but that's not what I want to focus this video on. So I want to give our student the same type of functionality that we had in our particle, and I should go ahead and make these vals. I want to have the ability to write it out to a file. Of course, the write is going to look a bit different. How do we write out their name? Well, the first thing I need to do is write an integer telling me how many characters are in the name. And then I want to write all of those characters out. The data output does have a method for writing a string. It's called writeUTF, but I'm going to go about doing it this way, writing it one character at a time. And there was actually a write_chars of string. Might actually be interesting to go to the API and look at what that does. Out.writeInt of ID. Okay, so that will write our student out to a file. We also want to create our companion object for the student, which has an apply method, which takes a data input, and I want to have this return a student. To read in the name, I need to do something along the lines of for I in 0 until in dot read int. I'll come up with I'll use a var here. This really is not the best way to build a string, but it'll work for our purposes. You really should use a string builder for this. Yeah. Name plus equals in dot readChar. The whole fact that strings are immutable and we're building a new string here every time makes this inefficient. But we're going to not worry too much about that right now. Okay, so this starts off with the name being an empty string, then it reads in the integer for how many characters there were, and it goes through that many times and appends a new character onto the string, and then at the end it reads the ID and it builds a new student using both of those. We don't have a record length here because the record length varies depending upon what is actually stored in the student. So now with that in place, I want to go and write a new ADT called a variable record length file. And to make this a little bit easier, I'm going to start off by copying the majority of this file. Okay, we'll have to, there'll be a number of errors inside of here. Let's put in our import for collection mutable. So what needs to change? Okay, so we had this file name here and a record length. I am going to actually use two files for our variable record length file sequence. One of those files, so the problem that we run into with these things being variable record length is, imagine the file has, for example, so the first record we'll just call A there, and the next record is that, and the next record is that. I don't know a priori. There's no way for me to, given an index, figure out where in the file that begins. Okay. So instead I'm going to keep a second file in here. And what it's going to do is it's going to say, well, A starts at 0, and B starts at, well, 0, 1, 2, 3, 4, 5, and C starts at 7, and D starts at, etc. So this is going to be my index file here, and then I'm actually going to have a separate data file. So we'll call this the index file name, and instead of a record length, because that doesn't apply here, we'll make this the data file name, and I'm going to create two random access files here. And the data file is going to be created using the data file name. Okay, so when we go to read something in, we can look up the location in the index file and then read that value. We still need to have a reader and we still need to have a writer because, once again, we're dealing with a type A. We know nothing about A. We're going to need some help from the outside code to be able to do that. We can write length very easily. The length is the index file converted to its length converted to an int, and then divided by, well, it depends upon what we're going to store in here. Turns out I'm going to store, in addition to the location, and because the file pointers, the file locations are longs, there's going to be one long for this 0. I also want to store how many bytes there are in this. So I'm going to store both a long and an int, which means that our index file is basically a fixed record length file itself, which has a size of 12 for every element, because there's the long and the int in it. Our apply method goes to the index file, and it seeks to that index times 12, and it's supposed to read in a long there, and we'll call that POS for the position in the file. Then we need to take our data file and seek to that position. And once we've done that, now we can actually read the value that is in our data file using the reader that was provided by whoever created this collection. So that gives us the ability to read and the ability to determine the length. Turns out that update is a fair bit more complex. Actually, we should go ahead and write our close method here. So why is update more complex? Well, there are a few reasons for that. One of which is the fact, what happens if I go to update the value that's stored here, but when I update it, the thing that I'm writing out is bigger than this. So our B took up 2 bytes. What if when I write it back out, it takes 10? Well, it turns out that in that case, I can't actually write it back out to the same location, otherwise it would overwrite C's and part of D. So I would have to then instead put all of the B's here at the end of the file and update this index so that it points to whatever that location was down there later in the file. Obviously, over time, this is going to lead to empty spaces, things that we're not using, and make our file overly large. So every so often you'd have to run through and reprocess these 2 files to compact things, basically put them back in order with no gaps in between them. But we're not going to write the code for that. In the next video, though, we will come back and work on update and figure out how we can do this procedure of writing things. So if it fits, for example, if the thing we wrote for A was 5 or smaller, we could write it right there. And if it was smaller, it's not a problem because we know where the other things start based upon the index file. But we have to put in this extra logic here. So we'll come back in the next video and we will write the update method so that it can do that.